Something comes to mind, but you're afraid. There's no need to be afraid. All flights have become dangerous. They are not dangerous. Although commercial aviation is incredibly safe, it is essentially based on a design from 70 years ago, which is why it has become boring and dangerous. I was shocked when I heard this, and you will be too. For decades, the metal casing surrounding every jet engine you see has been hindering the efficiency revolution. This company has placed a billion-dollar bet on this, which will either allow them to grow even more or sink further down. The technology in question is so radical that it completely eliminates NEL. Even 75 years ago, jet engines were important and began to be protected. Moreover, preliminary test results are not only meeting expectations, but exceeding them. Everyone is afraid of this, but Boeing is not afraid. Boeing is making a mistake here. It should be afraid here. This is not a distant concept. By 2028, the aircraft will reach the testing phase, and 7 years later, in 2035, it will begin flying. There is one confusing thing. That is, how can we destroy this aircraft in the shortest possible time with one move? We agree that metal cylinders are necessary for jet engines. From the CFM56 to the Pratt & Whitney GTF, every turbofan you fly is subject to the same basic constraint. The fan is limited, protected, and constrained. There are many issues, but the only problem may be the reduction. Consider the physics for a moment. Air moves up and down, and jet engines make this happen. Your fuel efficiency increases with the bypass ratio, or the amount of air that can pass around the core rather than through it. Today's most advanced engines achieve a bypass ratio of approximately 12:1. The fuselage of this aircraft has always been outdated, and jet engines impose restrictions, which also contribute to this. Imagine the enormous fan blades, each with a diameter of 8 feet, spinning while fully exposed to the airflow. Efficiency was not a concern in old traditional engines, but in new engines, efficiency is now at the highest level. For some, this is a cause for concern, but for others, it is not. It challenges everything we thought we knew about jet engine design, but the laws of physics cannot be denied. These engines can achieve bypass ratios of approximately 60:1, which is 5 times higher than the engines currently in use. Airbus places a high priority on emissions reduction and is achieving this through these new engines. This is not a gradual improvement. Reducing emissions is highly beneficial globally and positions the company as a leader in this area. But here's why this technology is so important to you. Your flight experience will benefit directly from these improvements. Fuel accounts for 30% of an airline's operating budget. It has become more expensive than even your average employee. That's why reducing emissions is a must. Competitive pressure ensures that passengers will benefit from a 20% increase in fuel efficiency. Better service economics, more route options, and cheaper ticket prices. Taking this step requires reducing emissions. Do you remember your last flight when the transformation became impossible and you had to turn your headphones up to maximum volume to drown out the engine noise? Here, every idea is discussed and change is a top priority. The purpose of open fan engines is to significantly reduce noise. Although it may seem counterintuitive, comprehensive acoustic modeling shows that traditional engines are louder, but winged engines are quiet, so it is better to use these engines. You can talk normally during takeoff. Children can sleep comfortably during the flight. You can work efficiently without the fatigue caused by constant noise that gradually drains your energy. No one is aware of this situation. These engines are noisy, and these noises bother us, but other things bother us more. In fact, this noise physically tires you out. During long flights, you feel very uncomfortable because you are trying not to hear this noise. Engines designed to prevent passenger fatigue are quiet engines. However, this is a much bigger issue than passenger comfort. Every flight with open fans can prevent tons of CO2 emissions into the atmosphere. When discussing a 20% fuel savings across the entire global fleet, there is no doubt that it protects the environment and has a significant impact on the climate. A regulatory reckoning is approaching for the aviation industry. Zero emissions are currently considered impossible, but they may be possible in 30 or 40 years. This may depend on agreements between countries. It is considered mandatory. If airlines cannot meet these targets, they may face heavy fines and potential route restrictions. In this technologically new world, everyone must move forward. Therefore, the sector is adopting a conservative stance in this highly regulated industry. And why is this company entering this field that no one else has ventured into yet? This company has incredibly smart owners, and they trust it. A wave of regulations is coming. According to EU regulations under Fit for 55, emissions must be reduced by 55% by 2030. Airlines that do not comply with these regulations may face heavy fines. And this company knows these circumstances very well, so it wants to act accordingly. To ensure its customers succeed in this new reality, it is currently investing billions of dollars. Nearly 3,000 engines are close to this agreement. Everyone is surprised by the situation. This is one of the largest technological investments in aviation history. However, what makes it interesting is the preliminary test results. Every prediction is being validated. Over 500 hours of testing have been conducted in a wind tunnel. In standard tests, real engines are not used. Instead, test engines that are suitable and similar are employed, so the data may not be entirely accurate. The information supports theoretical performance models. This speculation is not unfounded. It is a well-thought-out engineering project supported by concrete data. We have a question in mind. Why isn't anyone building this type of aircraft? Is it unsuitable, or would it eliminate competition? Other things are more important in aircraft, and it is necessary to solve those problems first. There is a danger in using these blades, as they are open and the propellers break when birds collide with them. This time, there is a greater risk of crashing to the ground. In the event of a catastrophic blade failure, conventional engines use NEL to control the failure. Completely new strategies are required to safely manage blade failure situations in open-fan engines. Some opt for sturdy blades made from lightweight materials to address these issues, and some tests are required to determine whether these processes are suitable for humans. The most rigorous testing procedure in any industry is certification. EASA and FAA do not merely test new engines, they subject them to rigorous testing. Severe weather conditions, contaminated fuel, extreme temperatures, any possible failure scenario. Testing can take up to 15 years, though some may conclude in a shorter time frame. It depends on the condition of the engine. This is why aviation holds the record for being the safest mode of transportation in history. The most comprehensively tested propulsion systems ever produced will be the open-fan engines that will eventually enter service. When discussing new generation aviation technology, this topic is often overlooked. How are these special engines produced? We will explore this together. The production processes for open-fan engines must push the limits of existing aviation production capacities. Open-winged engines are smaller than fan-driven ones. Everyone thinks they are large, but everyone is mistaken. The engineering challenges are entirely different. When traditional engines were designed, the precise production processes required for carbon fiber-reinforced polymer construction did not exist. These wings always operate at the stress threshold, and if something goes wrong, everything turns upside down. The aircraft cannot fly and remains in maintenance for an extended period. These open engines were forced to innovate, meaning authorities compelled them to adopt new technologies. Hundreds of millions of dollars were invested solely in production infrastructure. The puzzling aspect is why such a significant amount was spent. The impacts of this production revolution could extend far beyond the aviation industry. The latest composite production processes developed for open fan blades are also being used in the automotive, wind energy, and other industries that require strong, lightweight components. The scale of production required is staggering. If open fan engines are used, there are additional regulations that must be followed, which would require the production of thousands of engines. This is a highly unnecessary situation. The manufacturers of these engines are closely monitoring their competitors and producing engines accordingly. If they fail to do so, they will fall behind. Boeing is working on its own new generation propulsion technologies, such as research into hybrid electric systems and collaborations with Pratt & Whitney on sophisticated gear-driven turbofans. And these companies have made their bets, with some succeeding and others failing. As a result, an intriguing strategic dynamic is emerging. If open fan engines meet expectations, Airbus could gain a significant competitive advantage that could last for decades. Everyone would prefer this company, Airbus, because they talk about emissions everywhere and build environmentally friendly aircraft. However, if open fan technology encounters unforeseen challenges or certification delays occur, Boeing may be right to take a more cautious approach. While Airbus lags behind with its engines and other annoying issues, its competitors' customers go directly to the engines and use them with ease. Rolls-Royce, which has historically focused on wide-body engines, is closely following this competition as it develops its own groundbreaking propulsion ideas. There are technological similarities between open fan engines and the UltraFan demonstrator program, indicating that several manufacturers see similar opportunities. The Chinese also want these engines, so they are requesting permission to study and develop them. If open fan engines prove successful, you can expect Chinese manufacturers to quickly develop competing technologies. It feels like something from the future. It provides opportunities for future developments related to aircraft, enabling strategic studies on future aircraft. Successfully utilizing open fan engines requires more than just technological development. Significant changes must be made to the global aviation infrastructure. There is a lot of technological equipment in place for aircraft, and these engines are open air and widely appreciated. Completely new methods are required for the servicing, inspection, and maintenance of these engines. Existing maintenance platforms, air start vehicles, and ground power units were not designed for this type of engine. Those working there must undergo testing to learn these new technological materials, while others must receive training. Inspection procedures for traditional engines have been developed over the years. Systems with open fan blades are exempt from these procedures. However, there may be an issue here because training employees also means spending a lot of money and incurring millions in expenses. However, the real challenge lies in the fact that airports themselves may also need to undergo changes. Although open fan engines are generally quieter, they have the ability to create a visual effect with sound, which presents an opportunity, and there is also a need for social renewal. Door design may also be affected. Wider door openings or modified jet bridge configurations may be necessary for larger engine diameters. This is a necessity in aviation, and while there are obstacles ahead, there is also an opportunity to overcome them. The positive aspect is that this infrastructure development could accelerate further progress in aviation. New locations must now be created for these new engines, and they should not be used in places where older engines are currently in use, as there are new generation aircraft in the world that require engines suited to them, and their operating locations must also be adjusted accordingly to ensure proper flight performance. Major steps must be taken to develop these engines. Most people are unaware of how this has changed the geopolitics of international aviation. Being a pioneer of this technology in Europe is a positive development for you and for Airbus, as environmental performance is becoming increasingly important when choosing aircraft in developing countries. Aircraft with open fan engines may be preferred by countries with strict emission regulations, which could provide European manufacturers with a competitive advantage. Policymakers in Washington are also aware of this. In some countries, they are investing in developing a new system for clean flight. They are aware that falling behind in new generation aviation technology could have long-term strategic and financial consequences. In Asia, there are those who are following suit and seeking to do the same, notably China. The success of Europe's open fan technology could encourage China to increase its investments in competing propulsion systems, meaning that everything is going well for China. Open fan engines have the potential to revolutionize developing countries. Fuel efficiency is the sole reason why cost is no longer a factor in long-haul flights, meaning that money is no longer a concern in these flights. Connectivity can change the economic development expectations of countries that previously could not afford regular air services. International climate negotiations are affected by environmental issues. If 20% more efficient aircraft engines are successfully implemented, aviation's contribution to global emissions can be significantly reduced, which will give you the opportunity to learn about future emissions and speak on their behalf. Everything will be different in 10 years. When you take that step, it feels like you're in the future. When you fly, there will be silence, unlike normal engines, which are noisy. These new generation engines will even prevent you from speaking quietly because they are so quiet that your whisper can be heard everywhere. Safety announcements can be heard. The atmosphere inside the cabin is calmer. Talking is easier, and you can now do your work with a clear mind. Due to improved fuel efficiency, this ticket was more affordable than it would have been on older aircraft. This would be unnecessary for all aircraft, so it will be necessary for all aircraft. Fuel prices are making previously marginal routes profitable. Large cities are now offering direct flights to smaller cities. Landing sites for aircraft will change, and everything will be adapted to suit these aircraft. Above all, you are achieving a significant climate action without compromising on comfort or connectivity. The significance of this story extends beyond aviation technology. These engines use oil, but everyone claims that oil-free engines are less powerful, yet everyone is mistaken because they will be more powerful. This technology aims to provide better economy, lower emissions, less noise, and higher fuel efficiency all at the same time. While designing engines suitable for the environment, you may have reduced the engine's power, but it still means it is better than normal engines. If successful, this could influence how other industries approach environmental challenges. Advances in material science, efficiency improvements, and noise reduction techniques often find applications far beyond aviation. When people see these engines or when they begin to be used, everyone's opinion may change. This is radically changing the perspective on environmental solutions. You can go further with something better without having to restrict this technology. We are witnessing the development of aviation technology that could fundamentally change global transportation. This is not a distant speculative technology. These engines need to be tested, and appropriate 165E power levels need to be determined. The program is set. By the end of the 2020s, flight tests were conducted on the A380 testbed. Commercial readiness will be completed by the mid-2030s. And do you know what that means? Thanks to these engines, you will feel like you are flying in the future. The collaboration on next-generation propulsion is represented by the partnership between the most experienced aviation companies, Airbus, CFM International, GE Aerospace, and Safran. This technology is still in its infancy, and we will understand it better in the future because it is still in the development phase. You will be amazed when you see aircraft flying silently and comfortably in the future. The future of aviation is not just about transportation. It is about demonstrating that engineering excellence can solve important problems and improve the experience for all parties involved. This is what technological revolution looks like in the real world. These aircraft are now considered engineering marvels. Thrust power in aviation is currently undergoing a revolution. These tests will begin in 3 years and start flying in 5 years. Stay tuned to see them.